Welcome back. Today we are going to go through lesson 5.2, which is all about solving systems of equations by substitution. So we are going to be solving these algebraically today. We're going to go through when we have two linear equations, a linear and a quadratic equation, and then do some practice with it. So to start with here, we have two equations that we are trying to solve. Remember, the solution to a system is when the two equations that we are looking at have the same xy coordinate pair. You can see on the left-hand side, we have our steps listed out. Step one is to solve one equation for y in terms of x or x in terms of y. So we want to isolate one of the variables in one of the equations. So you'll see two boxes here. We're going to solve the first one and the second one just to give you an idea, but you only have to do one when you're solving it. So if we take that first equation, 6x plus 2y equals 10, and I want to isolate it. Let's say I want to solve for y in terms of x. I am going to isolate that variable. So I am going to get 2y equals 10 minus 6x. And then I'm going to divide everything by 2 and get 5 minus 3x. That would be one possible way of doing that. Another way we could do it, so this is an or, not an and, you just have to pick one of them, is to take that second equation and solve it for something. Let's say on this one I decide I want to solve it for x. I would rearrange the equation in order to isolate the variable that I want to get alone. So in this case, I would divide by 5 on both sides and get 4 plus 2y. Again, you just have to do one of those two. You have to isolate one variable in one of the equations. We're just showing you a couple different methods to do that. Now we're going to move on to step 2, which is to substitute the expression you just solved for into the other equation. For this, I am going to take y equals 5 minus 3x, and I'm going to substitute it into the second equation. So I am going to substitute into 5x minus 10y. Instead of y, I'm going to put what y equals here. So I'm going to say it's 5 minus 3x equals 20. So we want to make sure when we substitute, we completely replace the variable with what it stands for. The y completely goes away. Now we have only x's on our equation, which allows us to solve the equation for x. If we still had two variables, we wouldn't be able to solve. So the point of substitution is to get down to one variable that we're solving for. In this case, I would start by distributing. So I would have 5x minus 50 plus 30x equals 20. And then I'm going to solve that. I'm going to combine my like terms and get 35x. And I'm going to add 50 to both sides to get 70 on this side. Dividing by 35 on both sides, I get that x equals 2. So I have solved for x. That's my first step. Now, remember, a solution to a system is an xy coordinate pair where both equations are the same. So we now need to plug that in to one of our original equations to find the y value that goes with it. So going back to my equations, I'm going to say y equals 5 minus 3x, but instead of x, I'm going to substitute the value I know, which is 2. And I'm going to get that y equals 5 minus 6. I'm going to get that y equals negative 1. My one solution here is the coordinate pair to negative 1, where both the x and y come together. Let's do a couple practice with those down here. Looking at example B here, we have two equations that are linear. I'm going to isolate one variable. In this case, looking at the two equations, it looks like it's going to be easiest to isolate y in that first equation. So I am going to rewrite this as y equals 4 plus 5x. So I have isolated that variable, which is step 1. Now we're going to substitute that into the other equation for the variable we solved for. So in this case, it was y. So instead of y, I'm going to put 4 plus 5x equals 15x minus 3. The rest of the equation stays the same. Again, I double check. I am down to one variable here, so I can continue solving. I am going to distribute. And then I'm going to combine like terms. In this case, when I subtract my 15x, I get 0x's equals negative 15. So that means that 0 equals negative 15, and that is not true. So when we're solving and we get down to a place where we have something that is not true, we say that it has no solutions. Let's look at example C here. Again, we have two equations that are linear. I noticed that this first one is already solved for a variable. Y is already also isolated in that. So I'm going to go ahead and jump straight to step 2, which is to substitute. So instead of y in this second equation, I am going to put 2x plus 1. So I'm substituting in for that y. And then finishing it off. Again, I'm going to distribute to get 4x plus 2 equals 4x plus 2. And what I notice here is that both sides of the equation look the same. If I kept going, if I combined like terms, I would get that 0 equals 0. That is a true statement. When 0 equals 0, that means that any xy pair can be a solution. So we say it has infinite solutions. Next up, we are going to go through a similar process, but this time we're going to algebraically substitute with a linear and a quadratic system of equations. And so the last ones that we were doing were linear and linear. Now we have linear and quadratic. So step 1 here is to first solve the linear equation. So making sure you're focusing on that linear equation for y in terms of x. So I'm going to take my linear equation, negative 2x plus y equals 6, and I'm going to isolate that y variable. So I do that by adding 2x and get 6 plus 2x. Now that I have that, step 2 is to substitute that into the quadratic. So for the y, I am going to substitute 2x plus 6 and then set it equal to the quadratic that was there. All right, step 3 is now to solve that equation for x. Remember, again, we have x. Now, when we do this, we have a quadratic going on. So we should remember from our quadratics unit that we need to get it equal to 0 first. So I'm going to solve and get 0 on this left side. That means that I had to subtract 2x, and it means that I had to subtract 6. So I would end up with x squared plus 2x minus 3. Now, I'm going to use one of my methods for solving quadratics in order to solve this one. On this one, I know that this is factorable. I can think of two numbers that multiply to negative 3 and add up to 2. And that would be x plus 3 and x minus 1. So my solutions there would be that x is negative 3 and x is 1. Now that I have my x coordinates, we'll notice that I have two x coordinates. That means this system has two solutions. So I'm going to plug in the x coordinate to either equation, doesn't matter which one. I tend to pick the linear because it's a little bit easier, but you can choose to do either one. And we are going to find the y coordinates that go with it. So I'm going to start with my linear system by plugging in, or my linear equation, by plugging in the negative 3 for x. So that would be 2 times negative 3 plus 6. And that would get me that y equals 0. So my first solution is that when I have negative 3, I get 0. My second solution is 2 times 1 plus 6, which would be y equals 8. So I have 1, 8 as my other solution. Okay, let's practice 2 of those down here. Okay, for example, E here, we can see our quadratic and our linear. So my first step, remember, is to take my linear and get y alone. So that would look like 1 minus 2x. Now I'm going to substitute that into my quadratic for the y up here. So I would get 1 minus 2x x equals x squared minus 2x plus 3. All right, again, I have a quadratic. So on this one, I'm going to get it equal to 0. To do that, I have to add 2x, which means I have 0 x's left, and I have to subtract 1. So that gets me plus 2. So again, I have a quadratic here. I need to use one of my methods to solve. You have a couple options on this one. But I would maybe choose the quadratic formula since there's no b value. So I would say the opposite of b, which again is 0 because there is no b value, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. When I simplify that, I would get 0 plus or minus, which isn't going to change my value at all. So I would have plus or minus, when I simplify 0 squared minus 4 times 1 times 2, I get the square root of negative 8 over 2. And then we just want to be careful here when we're simplifying. Remember that the square root of negative 8 is imaginary. So I have plus or minus. It's imaginary because it's negative, and the square root of 8 can be simplified to 2i for the negative square roots of 2 over 2. And what that means, we know from that solution that it's imaginary. That means we have no real solutions. There's no intersection point on our graph. So we would say there is no solution in this case. When we're solving systems, we're looking for where they intersect on a graph, and this one wouldn't have any since its solutions are imaginary. Okay, let's do example F here. So for example F, I am going to take, now this one has quadratic and quadratic. You need to notice that up here. So for this one, they're both already solved for y, so they've taken care of step 1 for us. We're just going to substitute here. So we're going to have x squared plus 2x minus 3. So I'm taking this equation, substituting it in for y over there, and setting it equal to the other quadratic on the other side. So there's my system. Again, we have a quadratic, so I need to get it equal to 0. So on this side, I want 0. That means I have to subtract an x squared to get negative 2x squared. I have to subtract 2x to get me negative 4x, and I have to add 3, which gives me 6. So this is my quadratic I now have to solve. Again, you've got all your methods. You could quadratic formula it. I know that on this one, I can factor out a negative 2 and get x squared plus 2x minus 3. And then that's factorable. So I can go ahead and factor that quadratic that's left. Two numbers that multiply to negative 3 add up to 2 again are 3 and 1. 3 and negative 1, I should say. So my solutions for the x coordinates are negative 3 and 1. I need to now substitute those in to find what y coordinate goes with them. So I'm going to substitute in negative 3 to start with. You can substitute it into either of the quadratics that we started with. So substituting that in, minus 3, I would get 9 minus 6, which is 3. 3 minus 3 is 0. So when I plugged in negative 3, I got out a 0. And then we're going to do the same thing with 1. If I plug in 1, I'd have 1 squared plus 2 times 1. So that would be 1 plus 2, which is 3. And 3 minus 3 is also 0. So I would get 1, 0 as my other solution to this quadratic system. Okay, last thing we're going to do here is on the practice page. I would encourage you at this point to pause the video, go through all 8 example problems, and then come back and check your solutions so you have a chance to independently practice before you check. So I'm going to go through 4 examples fully, and then I will put the other answers on here for you to check your work. So I'm going to start with number 1. For number 1, I see that I have 2 linear expressions here. So I'm going to start by isolating a variable. I'm going to pick this bottom one just because I see that it's kind of nice numbers. 3, 6, and 24 are all multiples of 3. So I'm going to start by isolating x. I always pick the smallest one to isolate. So I would do that by adding the 6y to both sides. and then getting x alone. So that would give me 2y plus 8. Zoom in just a little bit more here so we can see it a little better. So for number 1 here, we've got our variable alone. Now I'm going to substitute that into the opposite equation. So I'm going to do 4 times, and I'm substituting my x that I just found in there, which is 2y plus 8, plus the 5y equals -7. So when I distribute, I get 8y plus 32 plus 5y equals -7. Combining like terms, I get 13y on this side, and on my other side, I get -39 when I combine those. That gives me a y coordinate of -3. Last step is to substitute that back in. So I'm going to say, all right, x equals 2 times -3 now is my y coordinate, plus 8, and that gives me an x coordinate of 2. So my final solution for that system is 2, -3. Okay, I'm going to jump down now to number 3. And let's look at that one. On this one, again, I see that I have 2 linears. So I need to isolate a variable. This one has some fractions, so I'm going to isolate that x because it's almost isolated. To get rid of that 1/2, I'm going to multiply both sides by 2. When I do that, I get that x equals 2y when I distribute that 2 plus 3. So now, not only have I isolated x, but I've gotten rid of the fractions, which makes it a little bit easier. So now I'm going to substitute that into the first equation. So I'm going to have 3 times my x, which is 2y plus 3, minus 6y equals 9. All right, I'm going to distribute to get rid of those parentheses. And then I'm going to combine like terms. So I have 6y minus 6y, that's 0. And if I move the 9 to the other side, I also get 0. So now we have a true statement, 0 equals 0, but we have no variables left. That means that we have infinite solutions. Okay, let's look at number 4 now. For number 4, I can see the top equation is a quadratic, and then I have a linear on the bottom. So I am going to solve that linear for a variable. This one, it really doesn't matter if you did x or y. I'm going to isolate y and get -x plus 4. And now I'm going to substitute that in for the y in that top equation. So I'm going to have -x plus 4 equals -x squared plus 2x plus 4. Now I have a quadratic, so I'm going to get it equal to 0. And when I do that, I am going to go ahead and move, just because it's a -x squared, I'm going to move the right side of the equation over to the left side. So I'm going to add the x squared, then I'm going to subtract 2x, so that gives me -3x, and then 4 minus 4, that gives me 0. So that is my equation solved. And again, we have a quadratic, so I'm looking at this one and I see that I can factor out an x as a like term. And I get my 2 solutions. X could be 0, and x could be 3. So last step, I have the x coordinates, now I need the y. So I am going to substitute in 0 to start with into my equation here. So I'm going to say y equals -0 plus 4. We know that -0 is just 0, plus 4 is 4. So my first solution is an x coordinate of 0 and a y coordinate of 4. And then my second one is to take -3 plus 4, which is 1. So my second solution is 3, 1. Okay, let's jump to number 6 now. Again, I have a quadratic and a linear, so I'm going to solve these again. This one is already solved for y, so I'm just going to plug it in. So I get x minus 3 equals x squared minus 2x plus 1. I'm going to get this equal to 0. So I'm going to cancel out this side by subtracting x to get -3x. and adding 3 to get 4. Now I have a quadratic that I need to solve, and this one I cannot factor, so I'm going to do the quadratic formula again. So I'm going to say the opposite of b plus or minus the square root of b squared, that would be 9, minus 4 times a times c, all over 2 times a, which would be 2. So when I simplify that, I get 3 plus or minus the square root. I have 9 minus 16 in there, which would be negative 7 over 2. And that means that my solution, again, like it was in one of the practice problems, is imaginary. So that means that we have no real solution. Now, those are the 4 that I'm going to go through, but hopefully you did the others as practice, and I will give you the answers to those so you can check your work. So for number 2, that one is also no solutions. Number 5, when you solve that, you get some decimals. You get 3.5 and 1.75. For number 7, when you solve it, there are 2 solutions, 0, negative 5, and negative 1, negative 4. And for number 8, you get 1 solution that's 0, 5. All right, we'll see you next time.